All right, thanks for coming. Want to start, Tim?
Hi, everybody. So here we're talking about Spark on Mesos. I'm Tim. I'm Tim Chen from Mesosphere. Oh,
Mike?
This mic. Oh, test.
So is this one not on?
Yeah, I guess this is not on. Hello, test. It's not even on.
Here we go.
Oh, there he is. Hi. All right, that looks way better. All right, so I'm Timothy Chen from Mesosphere, and both are mic'd up. And we're working on something called a DCOS, Data Center Operating System, which is based on Mesos. So we're going to go over, Dean will be going over Mesos for you guys, but we're very excited about data center and able to actually have a very nice abstraction over Mesos. So once you learn about more on Mesos, I'll talk a little bit about DCOS and Spark in general overall later on.
All right, so Spark is written in Scala, as you know, and Typesafe is basically founded by the guys who created Scala and middleware based around Scala, like Akka and Play. And so adopting Spark seemed like a natural evolution for us. And we saw a need to support Mesos for people who don't necessarily need Hadoop, running special scenarios where they'd rather have something more flexible for managing the entire infrastructure. And so we actually rolled out an announcement today that we're rolling out commercial support for Spark on Mesos, in particular for, DCOS. And if you want to learn more, you can go to Reactive Big Data at the Typesafe site to see more about it. But what the two of us are really all about, though, is helping you get safely through the treacherous waters of big data. That's what we're really all about. This came up today, by the way. This is a raccoon on an alligator. So let's talk a little bit about Mesos. Some of you may know a little bit about Yarn if you've worked with Hadoop. And it does similar things. It's basically managing resources in the cluster. And it has a very interesting model. It's basically two-level scheduling. And the idea is this. Your framework, which is the term for applications, is offered resources. And you can decide to accept them or not. And this is a way of doing like affinity. Like if you want to run in a particular server, you can just turn down everything until you get offers for that server. You can do things like this. So it's actually a very flexible model. And it's being used widely already. Apple announced recently at a meetup here in Silicon Valley that they're running the third generation of Siri on top of Mesos. It's a very large installation. And there's been a whole bunch of frameworks. Here's some bullet points. A whole bunch of frameworks now that support Mesos. You can run MySQL on top of it. Mesos was written by Twitter. You can run Cassandra, HDFS, which comes with DCOS, and so forth. So briefly, let me just walk you through how a resource offer would work, just to give you the gist of how it works. So imagine this is a typical cluster, obviously very schematic. Imagine I've got HDFS running here, and I've got some Spark applications that I want to run. So the way it starts is that one of the slaves sends a message to the master saying, I've got these resources. In this case, an identifier, slave 1. I've got 8 CPUs, 32 gigabytes. The master has a protocol for deciding who to send these offers to in terms of frameworks. So say it talks to Spark and says, look, I've got these resources. Do you want them? And let's say in this case, the Spark master comes back and says, I'll take half of the resources, half the CPUs, half of the memory. And I'd like you to start 2 tasks running on slave 1. And so the master then does that, it launches the tasks, and the rest of the resources are then available for other frameworks to use. And so that's really the gist of how it works. It's a very simple model, but quite effective for balancing load and so forth. And just a few other details about Mesos. It supports isolation mechanisms like Docker, Linux C groups, and so forth. And even has a protocol for you to plug in your own a containerization model. It's worth reading this paper that outlines the architecture of Mesos. There's some famous names on this paper, including Matei and Ali, as well as Benjamin Hinman, who's the guy that mostly created it. It all came out of Berkeley Research Labs together. There's an amusing quote, though, that I really like, and that is that to validate our hypothesis, we have built a new framework on top of Mesos called Spark. So this is the first mention of Spark. And of course, it took on a life of its own, as we know. And Tim will talk about Spark on Mesos. Use this.
So I'm actually curious, how many of you actually played with Mesos already? Like you actually tried out running some tasks and running some stuff. Cool, very good. How about trying Spark on Mesos? How have you actually tried Spark on Mesos?
All right.
Nice, nice. So I'm going to go over the different modes of Spark on Mesos. So I'm sure a few of you have tried, but most of you probably haven't really tried it out yet. So there's really, so actually first go over in Spark, there's one cluster manager that's actually able to distribute resources out. So when you have more tasks to run, you have Spark jobs you want to run, right? The first thing is to actually learn where are the resources and how do I distribute these resources to run what. So there's a cluster manager, and that's in play here. So in Mesos, basically, it's a Mesos master, right? Mesos, there's two components of Mesos. One is called the master, which handles all the resources, able to schedule resources between different frameworks. And a Spark, in this sense, is a framework that understands the Mesos protocol and receives offers from Mesos. So there's other frameworks that we talked about just earlier, right? So Mesos master determines how much resources are we able to give out to each framework. And then in a cluster manager here, Spark acts as a framework, as a scheduler, talking to the master, receiving offers, and determining should I use these offers or not. Right? Spark actually able to have this two-level scheduling to say, is this offer good for me? Like, does it have enough CPUs? Does it have enough RAM? And we have a lot more resources, like does it even have the ports or disk space that we need? And we're adding a lot more resources into Mesos. So you can imagine like network traffic flows, does it have enough bandwidth for me? And does it have actually any locality information that maybe I want to launch something else? So maybe I should wait a little bit longer until there's a good offer that I can use. So all these information is able to be determined on the Spark code side. This is a little bit different than most of the other cluster managers where everything is happening at the cluster manager level. You have to kind of send all the configurations to it, and hopefully it works as much as you like it to. But in the Mesos space here, we are able to, on the Spark side, to determine what resources we want to use. It's all local scheduling logic in the scheduler side. So there's two modes in Mesos, on Spark on Mesos. One is called a coarse grain mode. The coarse grain mode basically means I don't want to wait. For every Spark task, there might be multiple tasks that are running with multiple stages. But I want to run a long-running Mesos executor and a long-running Spark executor on every slave that I have available. Of course, it's up to a configurable amount, a maximum of CPUs. You don't want to take over the whole cluster by just running one Spark job, right? So there's a maximum amount of CPUs and maximum amount of Spark long-running executors that we want to run. And when there's tasks running, when we have a new Spark job and we have multiple tasks we want to run, we basically trying to just run these tasks directly to those long-running Mesos or Spark executors. So this is really great. This is really great for tasks, that has a lot more tasks, and you want to have really fast iterative sessions. So what this means is because you have these executors already running, you don't have to relaunch them again when there's new tasks available that needs to be run in a later run or later stages. But actually, the little downside is that since they're long-running executors, when you don't really need all of those CPUs being taken up by Spark, they can't be used by some other frameworks. Like if I'm running HDFS or I'm running some other interactive job that's running on Mesos, maybe if you're not really using all those resources locked up by the coarse grain mode, they can't really be shared yet. So the other mode we have is called a fine grain mode. So fine grain mode, instead of running a long-running executor per slave, we run just a really tiny Mesos executor that's also per slave. But we don't run a Spark executor per slave anymore. We run a Spark executor per task. So this Mesos executor is just a little process that's running and just waiting for a new task that needs to be running, that needs to run on Mesos. So when we find out there's new task we want to run, we actually start a new Spark executor. All the data is serialized and sent to the Mesos executor, and it will launch up a brand new Spark executor at that point. Register back to the cluster manager and trying to do all the startup initialization and run the tasks there. So the pros of using fine grain mode, right, is that you only use the amount of resources for that Spark executor when you need a task to be run. So when it's a much more dynamic sharing between other frameworks. So if I really care about how much resources my Spark is using, maybe it's a batch job. I don't really care. It's running slowly or it takes a little bit longer time to start up. But I really want to know, when I have resources available, I really want my other frameworks to really able to use this resources because maybe they're more important, or we have much more dynamic sharing between other frameworks. Of course, the downside is every new task requires a new Spark executor to be launched up, which requires more data to be serialized and waits for the Spark executor to be registered until it can actually be used. Okay, so just a little recap. So this is a sort of list of features we have on Spark on Mesos. And I added some ones marked with soon, means they already have open PRs, they're already be committed, they're pretty much ready to be merged. All right, so we haven't fully even merged into master yet. I'm just going to list them all here. So defining and course creator mode has been there for a long time. What we just added recently, 1.4, is called cluster mode. So cluster mode, you guys probably, if you use Yarn, if you use standalone mode, you're pretty familiar with cluster mode. But basically, you can able to submit your driver to your cluster and let your cluster manage those drivers. So for a lot of people, if you run your Spark job from your laptop, you'll have to be very careful. Before a Mesos, you had to make sure you don't close your laptop, otherwise your driver just blows away or just be gone, because the driver and the framework is actually running locally on your clients. But now instead, you can actually submit your driver to this Mesos cluster. And actually, there's another framework running your Mesos driver, starting your driver, and able to make sure that driver keeps running, right? Because it's also a long-running framework that's running on a cluster. And you can tell how much resources you want to start your driver as well. So we actually have a separate UI and stuff like that. Dean is going to demo a little short preview of little quick view of the cluster mode. We also added Docker support, right? There's already Docker support in Mesos. So why not able to launch all the Spark executors, also a Spark driver in Docker images, right? This way you can actually update Spark just by changing your tags. I want to use 1.5 RC1. You don't have to download, repackage, and put all the stuff you need and all the configuration change into the tarball. However you used this Mesos before, now you can actually just change your tag, and that's good to go. We're using support constraints. Maybe I want to launch my Spark task only on SSD disks, or maybe with specialized hardware. Now you can actually say, specify these filters and constraints on per job. What we're going to be adding soon is dynamic allocation and framework authentication. So dynamic allocation is one of the Spark features able to dynamically allocate, scale up and down the number of executors based on load and current queue task length. And firmware authentication roles are Mesos-specific features that is basically able to say, I'm a specific role in Mesos, and I want to guarantee have enough resources for me to run. And this is what Mesos supports. We call it static reservation. But all it means is, all these features that are Mesos already, we're finally getting into trying to support more and more on the Spark side. So this is good news. We're Typesafe and us, we're really trying to really move the momentum of Mesos on Spark, or Spark on Mesos, to really make sure we have all the bug fixes and all the nice features are running into Mesos. All the Spark users are able to empower the Spark users so they get all the niceties of Mesos as well.
All right, demo time. So what I'm going to show you, it's a little hard to demo infrastructure as opposed to like a graphical UI and make it exciting. So I want to give you a gist of what it's like to work with Spark on Mesos. And I'm actually going to use some features of DCOS that are just convenient for making it easier to work with it. So for example, DCOS has a command line tool that you can install on your laptop that lets you do things. Let me make this bigger, and nobody can see this, so let's fix that. I bet there it is. All right. Glad I noticed. And make this bigger. So for example, you can just install Spark with this command from your laptop or whatever. And I'm not specifying my cluster or anything. That's actually sort of embedded in configuration data. So this is pretty nice for installing packages, not just Spark, but others. And a related one is how it might actually run a job. So if you have the Spark command installed, then I could submit a job. And there's a lot of noise on this slide. But basically, I've written a Spark workshop on GitHub, shameless plug. And there's a streaming example in there. And so I just launched this on the cluster I have running which looks very similar to the Spark submit command you've seen already. It's basically doing the same thing, only in this time I ran that on my laptop and it sent it off to the cluster. I did have to pre-stage data in my HDFS on the cluster, as well as like the jar file for the application and all that. This is a trivial example. It's actually continuously reading a copy of the King James Version of the Bible and doing word count on it. But it's just a way of demonstrating streaming. So I did that in advance. I didn't obviously want to have it break right in front of hundreds of my friends, so we didn't do it first. But if we go over to the UIs and see what's actually going on now, it's been running for a while. Here's my mouse. You can't see this either, I bet. Nope. All right, let's fix that. And I'll make that a little bigger. So this is a little smaller, maybe. So this is the DCSOI UI, sorry. For my cluster, I have like 5 worker nodes down here, if I can find my mouse. And I get all kinds of information about what they're doing. I can see the services that are running. I have Marathon, HDFS, and Spark installed. And if you click through some of the web pages, you see things like this is the Marathon UI. I was looking at what Spark was doing earlier. And here's what I see when I click on the Spark link in the first slide. I get this view of what's actually happening. I had some drivers that ran before. If you look carefully, some of them failed, but we won't go into that. But the one that's actually been running now for a couple of hours is the streaming job. And I think I have one more here. And you can also get to the classic Mesos console if you want to see what's going on. For example, if you want to know that the driver was launched on a particular node, it's actually over here. What I want to show you, though, with this demo is actually something that I didn't mention in the command arguments. So if you look at the first argument after submit args, it's ---- supervise. And what this means is that Mesos is going to watch this job, and if for some reason something dies, it will restart it. And what I'm actually going to do is kill the, or basically delete the Docker image, and then have it just automatically grab it. There's the mouse, okay. And let's bring this window over. Here's the terminal window. It's a UI that goes back 50 years. Trying to make that bigger. Here we go. And let's do this so you can see it a little better. All right, so I actually ran this a little earlier. That's Docker PS. It's showing me that I have actually I've got 2 Docker images deployed. What I want to do, if I can operate this thing, I'm going to kill one of these. This is the Spark job. So Docker, I just did something I didn't want to do. What did I do here? Oh, hang on. There we go. Went back to small screen again. But anyway, you get the idea. So kill, and then that thing. And it probably, you know what happened? So this actually, this thing dies periodically, and it actually has been restarting it. I bet it's actually no longer on this node. So the fact that it was running when I went back to the other UI shows that it's actually been starting this over and over again. And it picks whatever, it gets offers for where to run this thing. So it's actually been migrating this driver around and running data as it goes. And if we look, so I'm not going to bother much with this now, but just to get rid of that, if I just show you the files in this data directory, and again, this is small, but you're going to see this long list go by. It's been writing these directories every 10 seconds or so for several hours. And if we look carefully at the timestamp, it'll be one of the recent ones because it just kept it running. So not extremely sexy, not as great as the Databricks UI, but you get the idea that infrastructure just works, and it helps you recover from failures. The last thing I'll mention, which I'm not going to, we thought about demoing this, but it turned out to be a little complicated for such a quick talk. But I do have a few pictures of it. And this is the dynamic allocation feature that's coming. Now, just to walk you through what it would look like just with a few slides. It's, once again, let's go back to the presentation. There we go. So you would say, this is like your config file. You would say, I want to run in course mode. I want to turn on the shuffle service, and what that will do is if an executor dies and is recreated, then it will actually find previous shuffle files and won't rerun previous steps. We'll see that in a second. And then you can configure things like the maximum, minimum number of executors, how long to wait when things appear idle before I just start reclaiming executors so that I make space, resources available for other users. And you can do this with like a trivial example, like just something like, something we've all written in the shell just to play around. And you get something that looks basically like this. This is one of my colleagues ran this recently. He had like 15 seconds for timeout. And basically, started this job on a 5-node cluster. It spun up executors. It ran that script I just described, and then saw that nothing was happening for about 15 seconds, reclaimed the executors. Those are the red bars. If you haven't seen this UI, this is from the new 1.4 console. And then when he started doing stuff again, it picked up where it left off. And the DAG visualization, the gray means that when it started up again, it could actually reclaim the shuffle files from the first stage, stage 2 as shown, and then it just skipped that and went on and did stage 3 again. So a pretty nice feature for both using resources efficiently, but also not losing work and having to recompute work. All right, so what's next for Mesos? Do you want that?
Cool. All right, so I'm also an Apache Mesos PMC, and so my day job, I mostly spend time working on Mesos. So I really want to share what's next for Mesos, what are features we're putting into Mesos that all the Spark users, once we integrate Spark on Mesos and have these features integrated, you can all take advantage of these. So what we're working on, of course, we're working on a lot of stuff. This is just maybe some highlighted things that I can remember top of my head, adding notes here. But what we're excited about is working on something called oversubscription, right? So most of the time, when you run any Mesos job, this is not even Spark specific, right? You need to specify how much CPU, how much memory, and how much any resources you want to use for this job. And most people overcommit. Most people say, my Spark job takes 4 CPUs and 3 gig of RAM, but in reality, it might only take 2 CPUs, or maybe it takes 2 CPUs most of the time, right? Resource sizing is a hard job, and it's actually very hard to come up with. What we're trying to do is there enough statistics, and is there enough feedback loop for us to determine how much can we size your task? And can we oversubscribe? Can we increase the utilization of your cluster overall, right? If everyone overcommits, we can still increase the utilization by detecting this overcommit and having some feedback mechanism back into the Mesos master and all these things to maybe have opportunity to use these Slack resources that we think those frameworks are not using. Right, this is great news. If you have a mix of really important services and jobs, maybe a mix of batch-oriented jobs, right? This is what a Google board paper has been mentioning about, right? There's a lot of variations of workloads and the variation of priorities. So what we can do is oversubscribe your cluster, use the Slack resources. Maybe you can run your Spark job in the background. That's something you want to run, but it's okay to be killed, right? You're using the Slack resources. We can able to say, okay, we understand, we detect some overcommits. We can give out these Slack resources to some Spark jobs to run. But when the listen these critical services wants them again, we can optimistically ask the framework, hey, we need these resources back again, right? So this is a good way to increase the utilization of your cluster. And for us to detect, based on statistics, based on your past history, these are our recommendation. We're still working on it right now, but we're very excited about oversubscription. We're working on networking overall. There's a lot of exciting things going on in schedulers overall. Anyways, there's like IP. There's IP per container. There's maybe some overlay networking across different hosts. But what this means is, for some really interesting scenarios where maybe you want your Spark streaming job to access some other resources that other containers or other Mesos jobs you're running, you can maybe access that through the same network that we set up for you, right? So there's a lot of interesting scenarios you can imagine. We're adding a lot more stuff, like a lot more isolations. So maybe not just CPU shares or not just memory. Maybe we can add more like CPU sets. Maybe I have a job that really requires hard pinning a CPU on a particular core. There's a particular reason you might want to do that, but just giving one example of one of the things we're thinking about, there's a lot more isolation you can add. And we already have block I/O support, network isolation. We have ports and disks. So we're adding a lot more. So I think Mesos we're doing a lot more to isolation support that all the Spark users can benefit from. So master reservations, all these really interesting features. All of this can be found on the Mesos Jiras. Right, so once we add all these features onto Mesos, and we can integrate into Spark, I think this is going to make the Spark scheduler have a lot more opportunity to do a lot more interesting scheduling decisions. And this is really able to utilize the two-level scheduling that's in Mesos. Right? Have Spark has a lot more control over how we want to really increase the performance of whatever Spark job is submitted to. I think that's the gist of our talk.
That's it.
So we're open for questions. Do you guys have any questions about Spark and Mesos?
Okay. Kubernetes?
Kubernetes. And like right now, for example, we're using Kubernetes with Docker and CoreOS. What benefits do we get out of it?
So yeah.
So I think the question is, how is it different between Mesos and Kubernetes?
Yeah, how do they compare?
Yeah. The second part of the question was that we're running currently Kubernetes with Docker and CoreOS, and what benefit would we get out of actually using Mesos over the current use case?
Yeah, and they're running Kubernetes with Docker and CoreOS.
Yeah, yeah. Well, that's a good question. So I think Kubernetes is a great project. You know, it's Google is driving Kubernetes. For us, I think Mesos has a lot more flexibility. Kubernetes is also handling all the resource scheduling on the Kubernetes side, right? So if I want to run Spark, and I also want to run MySQL, I want to run all these frameworks that has really specialized scheduling logic, it's really hard to express those in Kubernetes, because Kubernetes has sets different scheduling modes. I want to have bin packing, I want to have random, or I have to have really set-defined scheduling decisions. But when to Mesos, if I want to add locality, if I know I'm running a Spark streaming job, I want to spread out my executors in a specific way that only Spark understands. Or maybe Spark features are changing rapidly. I want to really play with around the scheduling. It's much easier to do those on a two-level scheduling model than with the Kubernetes model. So I think the gist of it is that we have a lot more flexibility in APIs and have a lot more power to do a lot more interesting things on Mesos side. Of course, Kubernetes has really nice concepts like pods, networking, and all those concepts. We're actually introducing them back into Mesos. And there's also integration between Mesos and Kubernetes as well. So I think even if you use Kubernetes, you can still use Mesos in the long run.
Hi. So my question is, I'm running Spark on Mesos, and this is great because multiple users can have different Spark contexts and be completely isolated and also run different versions. The problem that I had is that in my multi-tenant environment, some batch jobs end up consuming all the resources. And since we also have some interactive users, it would be great to have a way of limiting how much resources are offered to a specific Spark framework.
Yes.
Is that something that in there already and I missed, or is coming in the next version?
Yes, so there's a lot of work. It's hard to summarize all the work we're doing with multiple frameworks, but Spark framework itself already supports specific attributes to say, I only want to use up to a number of CPUs or up to a number of memory. So you can bound that, so to make sure it doesn't just overtake the whole cluster. Of course, there are things we're working on to make multi-tenancy or multi-frameworks works much more nicely. Like if I have a much more important framework comes up later on and want to take off the framework offers that Spark is using, maybe Spark is a less important framework. We're adding like resource, I think inverse offers or something similar to that. So able to say, I want to take back your offers because I have a much more important task to run now. So we're adding all of that features right now into Mesos so that Spark can take advantage of. But
also assigning a priority to a framework.
Yes, that's part of what inverse offers is about.
Or
yes.
Another concept that would be nice, since my cluster is on spot instances with auto-scaling, it would be nice to be able to assign a certain percentage of the resources and not a fixed amount.
So we're calling that master reservation. Actually, didn't mention it. Master reservation means I want to guarantee and maybe a percentage of resources reserved. It doesn't matter where in my cluster. Maybe 10% of my cluster is reserved for Spark. Make sure I carve out that much space for a particular framework. So that is going to be supported very soon.
So a lot of good stuff is coming. Thank you.
Yes. So right now, maybe there's not many exciting, sexy stuff in Spark and Mesos, but we're trying to integrate all of that because we're working very hard on Mesos right now.
Hi. My question is about the current status of the dynamic allocation and the long-running jobs. So do you support like CPU or memory level dynamic allocation?
So we don't actually, it's not our decision to actually allocate scale up or down. So there's something in the Spark code base itself. I think there's something called the execution manager or some kind of long-running thread is able to determine should I scale up or down based on the usage of Spark executors. So we're only integrating to a sense that Spark, that decision is able to translate back into Mesos, and Mesos is able to honor that decision, basically actually scale up and down. Because it's actually, all it does is calling to the cluster manager interface and trusting the cluster manager is able to scale back up or scale back down.
Okay.
So it's not really up to us about dynamic allocation. Yeah.